In this video, we're going to use trigonometric identities to simplify trigonometric expressions, such as the one shown here. Now, what are the trigonometric identities that we're going to use in this video? Well, here they are. There's a whole bunch of them. Now, we've discussed the Pythagorean identities in a previous video, so please make sure you've watched that video so you understand where these come from. We also have some other identities. We have the even-odd identities. Some of these trig functions are even functions, meaning that when you plug in negative theta, it's the same as plugging in theta. Some of them are odd functions, which means when you plug in negative theta, it's the negative of what you get when you plug in theta. And this works for any angle theta. So no matter what that number is, each of these equations holds. And that applies to all the equations you see on this sheet. We also have the reciprocal identities. These come from the definitions of how these trig functions are defined. So by looking at those definitions, you should be able to verify that fact. Well, all these facts. We also have the quotient identities. And again, these come from the definitions of these trig functions. So tangent theta is sine theta divided by cosine theta. Cotangent theta is cosine theta divided by sine theta. So we're going to put all of these to use to solve an expression such as this one. All right, well, what do I see here? I see sine of negative x. What can I use? Well, we have here the even-odd identity. I know that sine of negative theta is negative sine theta. So I know that sine of negative x is the same thing as negative sine of x. Cosine of negative x. Well, cosine negative x is the same thing as cosine x. So we can use that. And then I have secant x. Okay, what can I do next? Well, I'm not sure what I could do with any of this stuff, but I know that secant x appeared over here. Secant is the same as 1 over cosine, so let's use that. Oh, now I see. I can cross these off. I got one in the numerator, one in the denominator, and so the entire expression simplifies to minus sine x. That's as simple as this is going to get. Our next problem is as follows. We need to simplify this expression. All right, well, what can we do here? Well, I know how to express tangent. Tangent was on our identities. Over here? Nope, maybe not this one. Because I don't want to introduce cotangent into the problem when it isn't there already. I don't see how this could help us solve the problem. So let's look for a different one. How about this one? Sine and cosine. Sine and cosine are in our problem, so this one maybe it will be more useful for us. So I'm going to replace tangent with sine over cosine. Okay, what about secant? Well, can I write that in terms of sine and cosine? Let's see. This is secant, but I don't have negative. Oh, how about this one? Secant is 1 over cosine. There you go. That's the one we'll use. So I've just replaced tangent and secant with what they are in terms of sine and cosine. Let's see what happens here. Well, I can't cancel anything, but I can write this as sine squared x over cosine x. And I can write this as cosine squared x over cosine x. I could also cancel these, right? I could cancel one of the cosines with one of the cosines here, but then I won't be able to combine these fractions. See, I just got a common denominator. So maybe it's better if I leave it like this, because now that I have a common denominator, I can add these together. All right, can I simplify this? Well, I think so, because I remember seeing sine squared and cosine squared in my list of identities. Let's go look. Oh, there it is. Cosine squared theta plus sine squared theta equals 1, the Pythagorean identity. And that's exactly what we have. So this whole thing in the numerator is equal to 1. And what's that equal to? Well, I saw that in the list as well. 1 over cosine, 1 over cosine. There it is, right here, secant. 1 over cosine is the same as secant. And there is my final answer. All right, the last problem we'll look at. All right, a lot going on here. Not sure what I can do. Let's see. One thing that you can always try doing is writing everything in terms of sine and cosine. So you see this tangent in the bottom? Let's see if we can write that in terms of sine and cosine. Let's see. None of these, not that, not that. Oh, there it is. Tangent is sine theta over cosine theta, right? So tangent squared x will be sine squared x over cosine squared x. Okay, so let's write that over here. I'm not sure what to do with this piece yet, so I'm just going to leave it the same. All right, well, still not sure what to do. So what about this? What about this cosine squared over here? Can I do something with that? Let's look. Well, I do see a cosine squared here, and I see a 1 and a sine squared. So the 1, if I subtract cosine squared from both sides of this equation, I will have what I have right here, right? Just subtract cosine squared from both sides, I get 1 minus cosine squared on the right-hand side, and what's left on the left-hand side? It's sine squared. So the numerator here can be written as sine squared x, and that follows from this identity right here. So let's do that. Oh, okay. Well, now what I can do is I can simplify this, right? Because dividing is the same as multiplying by the reciprocal. So let's do that. Still not sure what to do with this. I'm just leaving it. But I do see that these cancel. Well, that's fantastic. Okay, let's come up here. All right, so what do I have left over here? I got cosine squared x plus 2 sine squared x. Well, you know what I'm going to do? I'm going to write that as sine squared x plus sine squared x. Why am I doing that? Well, because I know if I have cosine squared and sine squared, I have an identity for that. All right, so let's go, let's see if we can find it. And there it is. We used it once, let's use it again. Cosine squared plus sine squared is equal to 1. Okay, cool. Cosine squared plus sine squared is equal to 1. So this whole thing is equal to 1 plus sine squared x. And I think that's as good as I can do. If you look through the identities, I don't see anything there that's going to help us anymore. So this is our final answer.